What?
Were you asking me about a noise?
Never mind. I'm just gonna. Okay. Never mind. So yeah, just go to Ralston Valley's website and then academics teacher websites.
Hold on a second. My internet appears to be a little bit slow.
Okay, and then it's Hambleton with an H.
Algebra 2.
Yep.
And Quadratics, Unit 2.
Yes. And I want to go over systems of equations more.
Okay, where is that?
Hold on. So let's just go over normal quadratic equations.
I do see system of equations.
Yeah, I'm not sure that that's going to be on the test we have coming up. So let's go to just solving quadratics using any method. Yeah.
Okay.
Let's just go over that more. I'm sure we've done this before, this sheet, but I think it'll be best if, actually, no, we haven't done this.
No, I was going to say, I do not recognize this. I like it, what I'm looking at here. Okay, so for the following equations, use a different method to solve each different one. You have 4 methods, 4 equations. So, let's see if there is one that lends itself to one of the solutions better than the others.
Okay.
How about equation B?
Okay.
How are we going to solve equation B? If I just gave you equation B, you should pick the correct method. Which would it be?
Well, it's more simplified than some other equations.
Well, to use this method right here, you need an equation that does not have an x term. So it's not equation A, it's not equation C, it's not equation D. So I can solve equation B by taking the square root of both sides. What's the next line I'm going to, if I'm going to use technique 3 for equation B, what's my next line? Here, I'll write it down here. So, in other words, what's the next step? Because each of these methods kind of give you a different first step.
So we're doing square roots, right?
Yes.
So we would add one on, I'm not sure, but we would add one on both sides.
Okay, hold on. Let's do that. And now do you see why this method lends itself to square roots?
Yes. Okay. So we have to get the square, we make it x plus 5, and then it's just the square root of 1.
Which is?
1. Sorry, something popped up.
Plus or minus. That's the secret. When you are solving a quadratic by taking square roots, always start your answer out with the words plus or minus.
Okay.
That's probably the toughest thing of any of these 4 methods, is that I would say about 90% of my students forget the plus or minus. Okay, now let's finish the problem. If x plus 5 equals plus or minus 1, then what does x equal?
Equals -6.
It's one solution.
Well, plus or minus 6.
No. In other words, you don't do it quite like that. what I'm going to do is subtract 5 from both sides. You with me?
Yes.
Now, one of the answers is the plus, the other answer is the minus. So when I use minus 5 plus 1, I get minus 4. When I use minus 5 minus 1, I get minus 6.
Mm-hmm.
So those are my two solutions. And
Got it.
that's what you should always be looking for with quadratics, is two solutions.
Okay, got it.
Now and then you'll get one solution, but most of the time you get two solutions.
Got it.
Okay? All right.
Okay.
So notice that I didn't have to do any factoring. I didn't have to do any graphing. I didn't have to do any completing the square. Because all I had to do was put the number on one side and take the square root of both sides.
Mm-hmm.
All right.
Okay. So it's just gonna, yeah. So it would start off with, so would we always put that in the coordinate, or would it be, we put x equals minus 4, x equals minus 6?
Yes, that's the answer. In other words, the answer to this equation is x equal minus 4 and x equal minus 6. Now, notice, does that work? Well, if I plug in minus 4, what do I get? I get 1 squared minus 1 equals 0. That's correct. If I plug in minus 6, I get minus 1 squared, which is plus 1, minus 1 equals 0. So both answers work.
Got it.
Okay, and that is the correct solution. Now, let's see. Think for a moment. Let's see. If I tried to factor that, that would be 2x times x. It's got to be plus, minus, and I could do 3 and 5. It's got to be minus 5 and plus 3. Notice that that works.
Uh-huh.
In other words, that is that quadratic factor.
Okay.
Okay, produces the correct middle term of plus 1x. Produces the correct first term, produces the correct last term. So let's do factoring for a. Now, remember that that's equal to 0. So what are my solutions for a?
-5 and 3.
Not quite. Remember what you're doing. You're setting each of those quantities equal to 0.
Okay. So x could equal -3.
Okay, that's 1.
And
Set the other one equal to 0 and solve it.
let's see here, so 2x minus 5 equals 0.
Perfect. Keep going.
Would x be a fraction? It would be 5 over 2.
Okay. So now we've done the factoring method. Okay. Now, let's do this method because I can see that that's going to be the graphing method. How do I know that? Why is this easy to graph?
It looks like vertex form.
Exactly. Exactly. It is in this form right here. And when that is the case, I know exactly where the vertex is. Okay. So the vertex is where?
Isn't the vertex H? A is like the slope, kind of, right?
Vertex is H comma K.
Okay.
So in this case, what is H?
-2.
No.
Well, just 2 because it's
Exactly. H equals 2. You got to get the sign right. If you don't get the sign right, you're not getting the answer right.
okay equals 4.
Correct. Okay. Now, if I go, let's graph that. You're solving equation C. Okay. And so I'm going to graph 2 comma 4. I'm going to say that's my vertex. Is this, what kind of graph is this? Is it a straight line? Is it a parabola? Is it a circle? What is it?
It's just a point, right? And then it's a what do you call it? It's the I don't know
That's
what
the
the exact
vertex.
word is.
That's the vertex. But what is the
Yeah, it's
graph?
a
What is the figure called?
is the parabola the big like curve, the
Parabola is
big
correct.
U?
Parabola is
Yeah.
correct, yes. Parabola is either a U upside down or right side up.
Yeah.
Okay? Which one is this? Is this upside down or right side up?
This one's gonna be upside down.
Correct. Okay, so it's going to look something like this. But I haven't solved it yet. In other words, the solution is where I cross the x-axis. Right? In other words,
Yeah.
if I continue this parabola, wherever I cross, let's call this the x-axis and this the y-axis. Wherever I cross that x-axis, that's my 2 solutions. Notice that it's going to cross it in 2 different places.
Yeah, I remember learning that.
So how do I graph the rest of this?
Well, you use your A, don't you?
Well, let's solve this equation. Over
Got
here
it.
on the left, I'm going to solve this. Now, what it's telling me over here on the left is that I'm solving for when y equals 0. Well, when does y equal 0? It's when we cross the x-axis. So that's perfect. In other words, if I solve this equation over here, let's move the 4 over. So minus 4. Divide both sides by minus 1. And now how do I solve that?
Take the square root of both sides, so cos minus square root of 4,
Which is 2.
which is
2.
equals x minus 2.
Perfect. Now solve it. Give me both spots.
Plus 2 on both sides.
Okay.
Actually,
So what are my 2 solutions?
x equals negative 4, and then x equals positive 4.
No, if I move it plus 2 over there, it's 0.
You're right. Yeah, correct.
Right? So this tells me where my x-intercepts are. Because y is 0 at these 2 x points. So I know that parabola has to go through there, and it has to go through there, and that's my solution. X equals 0, x equals minus 4. And again, notice that if I plug in 0, it works. If I plug in if I plug in 0, it works. And minus 4, hold on a second. Did I make a mistake here? It's plus 4.
Yeah, I'm sorry, that's what I meant.
Yeah, because I noticed that minus 4 doesn't work. In other words, it does not satisfy that equation.
So that's not a coordinate right there that we have as our solution for x. That's 2x.
No, that is a coordinate. That coordinate is 4 comma 0, and this coordinate is 0 comma 0.
Yeah.
Okay, in other words, there's my x-axis, there's my y-axis. Okay? So, by graphing it, and solving it algebraically, we came up with the solution. So that satisfied that one and this one. Okay. Now we only have one more, and we're supposed to do it by completing the square. So
Got it.
let's complete the square. I'm going to write it over here. What's the one thing you do when you complete the square?
I don't know. It's the first one that we ever learned, I think.
You separate the x squared and the x term and put them together.
Okay.
And you would do it, put everything else on the other side.
Got it.
Notice that I have not changed it. That is still equation D.
Got it.
Just move the 15 to the right.
Mm-hmm.
Now let's complete the square. How do you complete the square? Inside the parentheses? That's always where you do it?
Well, we have to move it to the outside of the parentheses.
No. We're going to complete the square inside the parentheses. And you do it by taking half of the coefficient of the x term, and you square it.
And that's what it equals?
No. What's half of 14?
7 times 7, 49.
Okay, so I'm going to add 49 to the left side of this equation. And to balance it out, I'm going to add 49 to the right side.
Okay.
So I really didn't do anything. I just added 49 to both sides of the equation. I didn't change anything. That's always the secret. When you are completing the square, you want to go from line to line without changing anything. Now, the fact that we completed the square allows me to write that how? I don't want to write it as x squared minus 14x plus 49. I want to write it as a linear term squared. It's x minus 7. Whatever you got when you took half of that coefficient, that's what goes there. On the other side, I got 64. Right? 15 plus 49. Now solve it just like you've solved 3 of these others here.
X minus 7 equals plus minus square root of 64, which is 8.
Now tell me what x is equal to.
X is equal to either 15, or -1.
Good. Now, those are my 2 solutions. Okay. I could have also factored that. Notice that factors into x minus 15 times x plus 1. So factoring it would have gotten me there a lot quicker. I would have come up immediately with that. But they told us we had to use one method per problem, and we had already used the factoring method. So I completed the square on this. It kind of shows you that you can use any of those 4 methods for any quadratic. I could have used all 4 methods for each problem. Wouldn't be a bad exercise to do that. Just teach you all about how you solve quadratics. Those are the only 4 methods I know. And all 4 of them could have been used. But some are easier than others, like equation B. Well, it was all teed up for us. So all we had to do is move the 1 to the other side and take the square root of both sides, and we're almost there. All right. Let's see. We got about 10 minutes. Equation you are solving. Why did you choose this method? Solve through factoring.
How about you just write me an equation and I tell you what would be the best method to solve it?
Okay. Yeah, the rest of this page is those same 4 problems.
Yeah. Okay. So I just want to be able to recognize when a certain problem is
I got exactly what you mean. Okay? I know exactly what you mean. All right, hold on. Let me just write some equations. Go ahead. Which method?
This would be, I can't put the name to it, but we'd square root of both sides.
That's the name. That's the name of it.
Oh, square root.
Square root both sides. So what do I get?
You get x equals plus minus 5. So the answer would be x equals -5 and x equals 5.
Perfect. There's another way to do this. What if I put this 25 over here, make it like that? There's a fifth method.
What's that?
Well, it's the same as factoring. But if I said factor that, what would the left side factor to? And this is an important method. Difference of perfect squares. Notice that is a perfect square because it says x squared. It doesn't say x cubed. 25 is a perfect square, not 26. 25 is a perfect square number. And the two numbers are being subtracted. So that's why it's called difference of perfect squares. And it always factors. A squared minus b squared always factors into a minus b times a plus b. Okay? So x squared minus 25 factors into x minus 5
times x
plus 5, which gives you those two same solutions. X equal 5 and x equal minus 5. The advantage of doing it this way, never going to make a mistake by leaving out that plus minus sign.
Got it.
Okay?
This would be factoring, right?
Good. Let's not even do it since we don't have a lot of time. Let me just keep writing equations up there and let you try to solve them. Hold on. Let's make it like that.
It's an 8?
Mm-hmm.
Okay.
7. Looks like one that you can factor, right?
But it's not. We'd add
factor. That's the problem. So you got two other methods you can choose. One is you can use the quadratic formula. But there's another method you can use on this that was one of those four methods.
Is it graphing? Or no, that's not.
No, it's completely square. This is not in a particularly good format for graphing. I don't know where the vertex is. I don't know where the x-intercepts are. The one we did by graphing was in perfect vertex format, so we were able to graph it really easily. But how about if I say, let's complete the square on this?
Well, wouldn't we have to divide 8 negative? Well, we add 11 to the other side.
Let's get that number on the other side.
Yeah. So x squared minus 8x equals 11.
And always leave room here.
Always leave room. So dividing
that tells your brain what you're going to do. In other words, I'm preparing to complete the square.
A -8 divided by 2 is -4.
Square that.
That's
why it's called completing the square. So you always have to complete that square. So plus 16. You are always adding it, because even if it was a negative number like it is here, by the time I square it, it becomes positive.
Okay.
Got to add 16 to the right side so that I don't change anything. Now this is exactly the same as that, and that's what you should check every single time you write a new line. Make sure you have not changed it. Now tell me how I can rewrite this quadratic here. That's the whole reason I completed the squares, because I want to rewrite it as something.
X minus 8 squared equals 27?
Almost. It's x minus whatever you got when you took half of 8.
Oh, 4.
Yeah. Keep going.
X minus 4 equals plus minus square root of 27.
Good. So x equals, and the easiest way to do this second part here is just to put this number in front. For one thing, that gives you an answer that looks an awful lot like the quadratic formula would give you. And guess what? That's correct. That's what it should give you, is an answer that the quadratic formula would give you.
Yeah.
There's only one problem with this answer.
Could we simplify the square more?
I can simplify. Let's do that as the last thing. Tell me what this is equal to. Over here on the left.
Well, it's equal to the square root of, is it 8 or 9 times?
Remember, we have to find a perfect square factor. If we cannot find a perfect square factor, we can't simplify it. So if 9 is not a factor, then I can't do anything with it.
Okay, it's 7.
No, it's 9 and 3.
Oh, 9 and 3. Yeah.
Which
Sorry.
is 3 root 3.
Yeah.
That becomes 3. So I'm going to cross that out, and I'm going to put down here 3 root 3, and that is a necessary step. Had I not done that, I would have lost points.
Okay.
You always want to give radicals simplified. So the answer is 4 plus 3 root 3 and 4 minus 3 root 3. So that's what your two solutions would be for x.
Okay.
This one, because it's not factorable and I don't want to use the quadratic formula. So I'll complete the square.
Okay.
Okay?
Thank you.
You're welcome, Nathan. I will talk to you on Thursday. Same time, I think.
Have a good day.
You too. Bye-bye.
Bye.